Hello everyone and welcome to these short videos on the tips. So a pedigree diagram is actually a diagram that shows the pattern of disease inheritance in a particular family. That means from a pedigree diagram, you can actually say or interpret the type of disease inheritance that flows in that particular family. And then there are some signs that are usually used in drawing pedigree diagrams, which if you don't know what these signs stand for, it will be difficult for you to interpret a pedigree diagram. Now, when we have an empty box like this one, that means that it is a normal male. When you have an empty cycle like this one, it means it is a normal female. When we have a completely covered box, which can be in black or another color, it means it is an affected male. That is a male that is actually sick and is expressing the disease. When we have a completely colored box or circle like this one, it is an affected female. When we have a box that has been crossed like this one, it means it is a deceased male. When we have a circle that has been crossed like this one, it means it is a deceased female. When we have a box that has been shaded like this, it means it is a carrier or heterozygous male. That means he actually has the trait for the disease, but he does not express the disease. When we have a shaded circle like this one, it means it is a carrier female. Mind you, in most cases, this carrier male and carrier female, in some pedigree diagrams, they will not shade it like this. They will allow it as an empty box and they will not want you to interpret it based on the offsprings that are generated. Okay, so it is not in every case that you will see carrier male and carrier female being shaded. At times they allow it as an empty box. Now below is a pedigree diagram, okay? A cross between the parents, that is the man and the woman, is usually known as the parent generation or the P generation, okay? The offsprings that originate from this cross is usually known as the F1 generation or the filial generation or the first filial generation. Okay, now if we look at this pedigree, we will see that this individual here, this woman, okay, this woman here, this woman is not an offspring of these parents that were crossed at the beginning. So the woman has just been brought to be crossed with this man who is an offspring of the first parent or the parent generation. Okay, so this woman here is actually an external breeder. Okay, she is not a member or an offspring of that generation, so she has been brought in to be crossed with an offspring of the generation, so she is considered as an external breeder. Now let's solve an example so that we can better understand what or how pedigree questions can be set, okay, to better understand a pedigree diagram. So question 1 says that what type of inheritance is shown in this pedigree? That is the pedigree that is shown below. Then question 2 says what is the genotype of Romans 1:1? Okay, let's go to our pedigree. This is our pedigree diagram here. The first thing that we should note when we want to answer pedigree diagrams is that we should look at the pedigree diagram overall. Okay, we should try to see if the disease trait is a disease that skips generation. Okay, that means it is found in generation 1, absent in generation 2, found in generation 3, and so on. Okay, this is our generation 1 here, the cross between the parents. This is generation 2 here, that is the F1 or the first filial generation, and this is generation 3, that is Romans 3. Okay, so if we see a trait that skips generation, that can give us an idea that it is probably a dominant trait. Okay, but if it is a trait that, if it skips generation, it means, or it gives us an idea that the trait is a recessive trait. Okay, but if it doesn't skip generation, that means it is found in generation 1, generation 2, generation 3, in all the generations. That can give us an idea that it is a dominant trait. Okay, now getting back to our question, this pedigree, we might be tempted to say that this is a dominant trait, okay, because we see that in the first generation we have an affected individual. In the second generation, we have an affected individual. And in the third generation, we have affected individuals. Okay? But now, let's look at this cross in Romans 2, the cross between Romans 2:3 and Romans 2:4. Okay? When we look at the cross between these two individuals, we see that both of them are healthy. Okay, both of them do not express the disease. Okay, but they give rise to offsprings that are affected. That is, Romans 3:7 is affected, Romans 3:9 is affected, and yes, Romans 3:7 is affected, and Romans 3:9 is also affected. Okay, this will just tell us that this disease is a recessive trait. Okay, because it is skipping generation. Okay, because if we look at Romans 2:3 and Romans 2:4, they are not sick, but they give rise to children that are sick. That means it is a recessive trait, and we see that here in Romans 3 or Romans 2:3 should be a carrier, and Romans 2:4 should also be a carrier. Like what I was saying in the previous slide, we see that they are carriers, but here in this question they have decided not to shed them. Okay, they have decided not to shed it. Okay, to make the question more complicated, so that you can reason out what the trait is based on the offsprings that they produce. Okay, so that tells us that firstly it is a recessive, that disease trait is a recessive trait. Okay, it is recessive. Then now the second question, how do we know if it is autosomal or it is sex linked? How do we know if the trait is autosomal or it is sex linked? We have already deduced that it is recessive. How do we know that whether it is autosomal or it is sex linked? Okay. Now we still come back to this our cross between Romans 2:3 and Romans 2:4. Okay. Now, for them to produce offsprings that are sick, there must be both Romans 2:3 and Romans 2:4 must be heterozygous, okay? Or they must be carriers of that trait, okay? Since we have deduced that it is recessive. But now, in a sex-linked or X-linked inheritance, Romans 2:3, this one, Romans 2:3, this man here cannot be heterozygous. He must be sick because a man has just a single X chromosome, okay, and a Y chromosome. The Y chromosome does not carry alleles. So if the man has just one X chromosome, then and the man is heterozygous, the man must be sick. Okay, let's say this small n stands for the disease trait. Okay, so if this man carries just the single mutated copy of the allele, the man must be sick. But here the man is normal. Okay, and for them to produce offspring that are sick, that man must be heterozygous. Okay, that can only tell us that since if it is sex linked, the man cannot be heterozygous. The man is either sick or he's normal due to the fact that he has just a single X chromosome. That means that this should be an autosomal trait, okay, an autosomal trait. Okay, so for question one, that inheritance, it is an autosomal recessive an autosomal recessive inheritance, which is a form of Mendelian inheritance. Okay, so the inheritance there, it is an autosomal recessive inheritance. Okay, so what is the genotype of Romance 1:1? We have with this Romance 1:1 here. What is the genotype of this individual? Okay, we have seen that a cross between this man here, that is Romance 1:1, and this woman, Romance 1:2, gives us an offspring that is sick. Okay, and a normal offspring here, and an individual that is normal. Since we have deduced that it is a recessive autosomal trait, this can only mean one thing. This can only mean that Romance 1:1 must be heterozygote in order for them to produce an offspring that is sick. So the genotype is that individual should be heterozygote. So this is the genotype for Romance 1:1. Should be heterozygote or a carrier. In other words, heterozygotes mean that he is a carrier of that disease trait. Okay, so this is how we interpret pedigree diagrams. Okay, and I hope this presentation or this video has helped you understand how to interpret pedigree